Hello, welcome to Life Matters. I'm your host, Brendan O'Connell. Well, when I first got into this whole area of being pro-life, I had no idea that there were many topics that were going to present themselves that have to do with life. And we're going to look today on the science and biotechnology side of life. And we have with us a very distinguished guest, William Hurlbut. He's a medical doctor and a professor, a consulting professor in the Department of Neurobiology at Stanford University Medical Center. He was born in 1945 in St. Helena, California, but he grew up in Bronxville, New York. What a dichotomy right there. And after receiving his undergraduate degree in 1968 and medical training degree in 1974, both at Stanford University, he completed postdoctoral studies in theology and medical ethics. He studied, for instance, with Robert Hamerton Kelly, the dean of the chapel at Stanford, and subsequently with Reverend Louis Boyer of the Institut Catholique de Paris. In addition to teaching at Stanford, Professor Hurlbut served for 8 years on the President's Council on Bioethics from 2001 to 2009. Well, welcome, Professor William Hurlbut.
Thank you.
Professor Hurlbut, you have one of the things here in Massachusetts that interested me quite a bit was you were influential in changing the mind of Mitt Romney. I was at the the Republican state convention where he had given a speech when he was going for governor the first time. And he said that, basically he wasn't going to change the laws regarding abortion. He was subsequently elected. His lieutenant governor was ardently pro-abortion. In fact, Planned Parenthood hosted her cocktail party after the convention. How did Mitt Romney come to change his mind regarding his pro-life position?
Well, I was invited to speak with Mitt Romney in his gubernatorial office in the State House during the intense controversies over embryonic stem cell research. And at that time, Mitt Romney was reconsidering the implications of the basic positions that he had had with regard to the life of the human embryo and the laws concerning abortion. And I think what really changed his mind on the issue more than any single thing, because he'd always been personally against abortion, but he started to realize that his positions made a certain logic of justification for the instrumental use of human embryos in research. And that opened him to further considerations of the implications of the position that so many people had taken, that he had also kind of passively taken with regard to abortion. He saw the seriousness of using human embryos as a raw material in scientific research, and that there was no logical stopping point based on the idea that a woman would have a right over her embryo well into pregnancy or all the way through pregnancy. We might end up using not just embryos but fetuses as well. So it was a very intense conversation, and I talked with him for several hours, and he was a very remarkable person to talk with because he was very fast in his mind, asked all the right questions, and had a deeply sincere spirit of seeking the truth and goodwill. So it was an exciting moment in my professional life.
Well, that's terrific. I know I saw him speak the first time he ran. I saw him speak at the National Right to Life Committee convention in Kansas City, Missouri. And there was quite a bit of skepticism that, he just changed his mind because he was running for president. Do you think that's the case?
No, I don't think that's the case, because fortunately, people can change their minds on things. They live life longer, they experience deeper realities. He spoke to me about the experience of having raised children and how that had deepened, as it does with many people, the sense of what the mystery is from the earliest moments of conception on, the unfolding of a life. Most people who are pregnant refer to the life in the womb as their baby. And they don't say, my fetus or my pre-baby or something like that. They think of it as a full member of the human species, emerging in a mysterious, unfolding way, but nonetheless a human being with rights, dignity, and all the joy of welcoming into the world. I think he experienced that, and I think he also saw the seriousness of the issue with increasing clarity, as many of us have. I think many people have slowly come to see that the longstanding traditions of Western medicine and Western culture, and to some extent the whole world, honoring developing life, are very sound, that our modern ideas are just an aberration in the history of humanity, that we should indeed recognize that life begins at conception and ends with natural death.
I see. Now, I'd like to switch to, during that hot period of discussion, in most articles, the headline just said stem cell research, and it wasn't until the next to last paragraph where you would get into the word embryonic. But you had proposed something that was maybe a bridge between two warring factions back in the 2003 to 2007 or 8 time frame, called altered nuclear transfer. What brought you to this thought about research and society as a whole would benefit by altered nuclear transfer?
Well, I put forward that proposal in the spirit of finding a way forward that would allow us to get the equivalent cells to embryonic stem cells, but not with the use of and destruction of human embryos. And let me back up a second and tell you the overall thinking. At that moment, and everybody who was an adult at that time remembers that before 9/11, the stem cell issue, embryonic stem cell issue, was one of the most intense public debates we've ever had, at least in my lifetime. President Bush's first address to the nation was on embryonic stem cell research, and in that address he said he was going to appoint a President's Council on Bioethics, to which I was later appointed in that fall. And so this was an intense debate, and the reason we were at that place in the process of our civilization and our species was because the advances throughout the 20th century culminated in the sequencing of the human genome and increasing knowledge of how cells work and how human beings are formed. But these studies were accomplished through the breakdown of the systems into their component parts. We had the Human Genome Project looking at the DNA, and we're looking at the proteins and so forth. But about that time, just at the end of the 20th century, we're finally ready to see how those parts knit together to produce a living human being. So we were entering the age of developmental biology, the study of living things, not just their component parts. So that reopened the most fundamental questions concerning the relationship between the material form of something and its moral meaning as a developing human being. So that was the context in which the embryonic stem cell debates emerged. And so when I was sitting on the council pondering these matters and the possibility of great good in science, but also the very deeply important moral issues concerning the respect and integrity of human life, I thought to myself, isn't there some way we could technologically bypass this problem? And I remembered during my medical training, I'd seen tumors that were produced by abnormal ovarian processes where they'd produce something that looked like a bag of jumbled puzzle parts. It was human parts, but without the integrated unity of a whole. This is a kind of tumor called a teratoma. And I thought to myself, nobody considers this to be a living human organism. We routinely take these tumors out in medicine, and we don't think of them as abortions because they're not living human beings. Nonetheless, the process was clear that you could produce something like embryonic stem cells in the process because these tumors have developed tissues, cells, and sometimes even partial organs, hair, fingernails, and teeth inside a tumor in a woman's ovary. It's a little grotesque, but it's also fantastic because it meant that we could isolate the powers that were producing this capacity in the cells, but without a living human organism. So I proposed a way to do this, and it was a viable thought. We assembled a series of very, very high-level theologians, scientists, policymakers, including several representatives from the church, various churches, And we debated whether this would be a moral way to go forward, and our resolution was 100% unanimous that this would be morally acceptable. But then, and then later, the President's Council did a whole report on this and several other ways of getting the same cells without producing embryos. And one of those ways, a few years later, was successfully accomplished by a Japanese scientist, and so we haven't had to use altered nuclear transfer up to this point. But it may reemerge as a possible project again because science is continuing to evolve.
Oh, was
so
that
that's sort of the general background on that.
Was that the induced pluripotent cell? Is that what you're talking about?
Yeah, that was produced by a very nice scientist. I've had conversations with him, Shinya Yamanaka from Japan, and he figured out a way to use basic components of development to convert older cells, like adult skin cells, back to the state of pluripotency, which is the unique power of embryonic stem cells, but without embryos. And his method has been very widely adapted in scientific labs all over the world, and he got the Nobel Prize for this just a few years later. And by the way, a little footnote on this. When I proposed my proposal, and there were others too, as I said, the United States was unable to form agreement to even investigate these. And twice, bills went through Congress, one sponsored by Rick Santorum and Arlen Specter, two different views on the whole issue. But this passed the Senate 100-0, but then was rejected by the House. And then a subsequent bill went through the Congress and also endorsed funding for these approaches, to investigate these approaches. And we argued and debated and couldn't seem to find the resolution or the funding to support these projects. Meanwhile, in Japan, Shinya Yamanaka did it for just $100,000 of private money in a lab. So that's a failure of democracy and failure of respect for diversity of opinion. We should have turned our resources to resolving this issue, not fighting about it.
Mm-hmm. I see. And now I'd like to ask you about something that was brought up. You brought it up, and it seemed rather foreboding. Then that is the acronym CRISPR. What is the acronym CRISPR, and what does that have to do with the future of biotechnology and science?
CRISPR is a, as you say, an acronym for a scientific process and condition that speaks of a mechanism by which bacteria fight off viral genetic DNA and RNA that is going to infect the bacterial cells. And this kind of procedure has been adopted by scientist. Several scientists in the world have been instrumental in this, but among them is Jennifer Doudna of UC Berkeley. And Jennifer figured out a way to take this mechanism in the cells of bacteria and apply it more broadly to all sorts of cells, all kinds of cells. So it's a major new tool that has greatly increased efficiency, specificity. It's much less expensive and much faster than our previous genetic editing tools. And it goes well beyond just substituting genes or knocking genes out. It's become a tool with a lot of potential. It's sort of like a scalpel that can cut DNA, but it's also more like a Swiss Army knife with multiple possible interventions in genetics. And the meaning of this, the significance of this practically, is that we're going to get vastly accelerated developments in scientific research, medical research, and also in new products, agriculture, and probably a whole range of things we haven't yet thought of. I compare this moment in biotechnology to the earlier experience of human civilization with the discovery of electricity. When electricity was discovered, few people had an idea how many applications there would be and how transformative it would be. And I think that CRISPR, the new gene editing tool, is likely to have a huge, huge impact on the future of all of life and future of our civilization for sure.
And is that going to, what are some of the ethical and moral concerns you have? Is it, biotechnology is on a plane and the moral and ethical discussion is on horseback, trying to catch up with all these advancements?
Well, unfortunately, that seems to be the case. But fortunately, the John Templeton Foundation has just awarded a grant to Jennifer Doudna and to me to work together on organizing ethical, legal, and social discussions of this and public outreach to engage the insights and intelligence of the whole human family, because these kind of issues are not just issues for the private thinking of scientists and their projects, and they go beyond their positive medical application. They actually involve very fundamental issues of what we think nature is, what our rights over nature are, what is legitimate to alter within the natural world and in human nature. And for the first time ever, it's becoming feasible to change human genetics, both in embryonic life and perhaps later in life too. In fact, almost certainly, so that we can intervene not just in diseases, but maybe make some efforts to enhance human beings towards some kind of transhumanist future evolution. Now, I don't want to exaggerate those possibilities because I think a lot of the statements on them are hyperbolic and speculative, and some of them are ridiculous. But nonetheless, these are new powers over human life. You stop and you ponder what this means. For the first time in the billions of years in which life has been on our planet, life has gotten control over itself at some level, and very deep levels. And this means that we have to stop, we have to ponder, we have to ask ourselves, where did life come from? What's its source and what's its significance? What rights and responsibilities do we have in the use of it? And how do we wisely guide these technologies so that we don't disrupt not just the natural world around us, but our own human nature? Look what we've done to the natural environment with our arrogance and our greediness and so forth. If we do that to our own bodies, to our own species, we will regret it very deeply.
Well, now, is the 21st century going to be one of genetic determinism then?
Well, it turns out that genes are not as deterministic as we think. And I know that's a very logical question to ask, because if they aren't deterministic, then what difference does it make to alter them? Well, there's a moderation between those extremes. Some things are more determined, like, for example, red hair. There's a single gene that causes red hair, and you get it if you have the gene. But complex traits about which we are mostly concerned, I mean, most people, if they thought of the first line of intervention, of course, would be against disease. And that, for the most part, would be legitimate if it's done in a way that respects human life. But then when we come to the idea of changing human beings, there's huge ethical problems with regard to its application to early embryonic life, and even involves the experimentation with embryos. Those are very, very real human issues. I want to come back to that in a second. But first I want to say the kind of things that people want to do beyond healing diseases, ideas like improved intelligence, beauty, longevity, and these are things you might say, well, what's wrong with that? But even if there is something right with that, which I think is open to debate, the complexity of doing it is going to probably transcend our powers for a long, long time, and maybe forever, because unlike the deterministic notion, genes are not like Legos. They're not like you just don't put them together and get new constructions. They're not like Mr. Potato Head, where you put on a new nose or a new eyebrows or something. Genes are much more complicated. They interact with one another. Their products, protein products, interact with one another. And the result is that most traits we care about are caused by dozens, if not hundreds, of genes. And so any changes will involve a vast amount of change, not just of the traits we're aiming at, but of many traits at once. So this is not going to be easy, and that's probably good, because in our arrogance, we might proceed too fast. Now back to embryos. That's a very, very complicated matter. When CRISPR first emerged a few years ago, it was recognized right away by the scientific community and by many others that this would be an amazing tool for studying early human development. But the problem is that it involves the intervention in human life and often the instrumental use of human life like it's some kind of a resource for a laboratory. And so there's a big controversy going on, and the National Academy of Sciences organized an international summit last December to talk about this whole idea of what they call germline intervention, very early determinations of human genetics. And the strangeness of this problem is that in order to fast forward such projects, you would need to do a lot of laboratory experiments with embryos. So that the debate about whether we should do this or not is likely to end up being more bitter even than the embryonic stem cell debate. I think it's going to make the embryonic stem cell debate look like mere prelude, because this has tremendous power for deepening our scientific understanding, but also a very dangerous potential for involving a desecration of human life. I mean, we don't want to degrade the very humanity we're trying to heal. So we're up for some very big controversies in the future, but meanwhile we're preoccupied with trivial matters in the press and our politics, and we're just drifting around while the great, big, huge problems that are going to impinge on human life in the future are being neglected in general public debate. So that's part of what Jennifer Doudna and I want to do, is stir up a really deep, thoughtful public dialogue, as well as high-level dialogue between scientists and scholars, and try to figure out what's good for the human species, because these are definitely global issues. They're not just parochial issues for given societies. They're species issues that need to be addressed by international cooperation and affirmation of the dignity of human life.
I wanted to ask you, because the profit motive often gets involved with some of this, are genes a patentable event, thereby providing a new gold rush at the U.S. Patent Office?
Oh, well, that's a question that has a history that's quite fascinating, actually. With the Human Genome Project, there were significant efforts and indeed patents granted for genes, and one of the most famous ones was for the gene that is associated with breast cancer, BRCA, it's called. A company took a patent out on the gene itself, the natural gene, even if it's a pathological gene or associated with a pathology, it was still a naturally occurring gene. And for a while they were granted the patent, but in, I think it was 2013, that patent was overthrown. And the basic thinking now is that, at least in the United States, it's different all over the world, but in the United States, you cannot patent a gene if it's a naturally occurring gene within a given species, but you can patent alterations and you can patent processes. So yeah, there will to some extent be this kind of gold rush quest, but fortunately we're starting to respect the sort of general gene pool of humanity as a species, as ownership by our species, not by any individual. You see what I mean?
Yes, I think I do. Well, Professor Hurlbut, I wanted to ask one other question. This has to do, can ethics and morals be uniform from country to country to deal with CRISPR and to deal with all the biotechnology advancements that are occurring? Do you think that would ever be possible?
Well, that's a very profound question, and we can see that even within our own country, there is disagreement about the beginnings of human life. I mean, I know many scientists who I personally feel you need to honor human life from its beginnings, and I'm decidedly pro-life in that regard, and yet I know many scientists, intelligent people of goodwill, who say, oh no, you don't really become a human being until you've got certain dimensions of form or function, and some go as late as to include self-awareness, self-consciousness, And some have actually gone beyond the boundary of birth, saying that if parents want to actually put to death a child who's somehow not up to their standards, maybe because of some genetic defect or something, they can do so after birth. Among advocates for that have been the Nobel laureate Francis Crick and the philosopher Peter Singer. So you see there's not even agreement within our own civilization. But let's say that we did get agreement, at least by majority rule. Then we have to deal with a complex reality of diversity of very deep metaphysical, religious, philosophical questions throughout the world. And I read something recently from a scholar in China that said, in China we don't believe, but based on Confucian teachings, we don't believe that you're a human being until birth. Well, the implication of that might be that you could then do anything you wanted to an embryo or fetus until birth. Now, I'm not trying to assign negativity to the Chinese. We need to get into engaged conversation and really hammer out these issues. But hopefully society as a whole will collectively, globally, will find some ways to honor human dignity in these regards. But it's going to be a long and difficult process, partly because so much scientific advance can be achieved if you just ignore ethical issues. And increasingly our own companies from our own country are outsourcing their ethical dilemmas to places where they're not against the law. So we're going to face a very, very difficult future.
Well, Dr. Hurlbut, thank you so much for coming on the show today and explaining some of the areas that we really need to look at and seriously discuss in the future and decide where as a humanity we're going in our biotechnology and our ethics and morals as societies around the world. Thank you.
Let me just say one last thing, and that is that as frightening and concerning as many of these prospects are, they also hold tremendous positive possibility. So, like Moses said to the people in the desert, today is a blessing or a curse. We need to choose the right way, and that is consistent with our deepest understanding of the source and significance of human life.
Well, thank you, Professor Hurlbut. And we hope you found today's show to be unique, informative, content-rich, truthful, and thought-provoking. Thanks for watching. I'm Brendan O'Connell, your friend for life.